Hello, welcome to my tech fun. I'm Igor and Kingroon sent me another 3D printer for the review, and also I got this 3-color filament for the testing. This is KLP1, a CoreXY printer based on Klipper, and it is also enclosed. It used the linear rails on X and Y axis, and on Z axis it used the linear rods and the ball bearings. The print volume is 210 mm in X, Y and Z direction. The printing speed is 350 mm per second. This is quite big speed, and the acceleration is 10,000 mm per square seconds. But somewhere on the website I can see 520,000 values. Now, very interesting data. The price is only $379. Of course, depend on your country and other taxes. This is with the touchscreen version. So this is very low price for this kind of specifications. It uses a 5:1 gear ratio extruder, and it has the built-in accelerometer, for the input shaping. Now, I couldn't find information about the maximum printing temperature. Does it use the Teflon line hardened or all-metal heat break? So I posed the question to the support, and I'm waiting the answer, but you can see their answer here. But I think it's time to see what's in the box. Everything is nicely packed and protected during the shipping in this white foam. And a surprise, almost fully assembled printer. This is content of the box. As you can see, it is almost completely assembled. And we have some sample PLAs, which I really hate. I really like better when it's on some small spool. There is some kind of pen, maybe for the touchscreen, and you will not have those fingerprints. Nice idea. Power cables, some tools and bolts, and this is the user manual, USB disk, and these are those plexiglasses which will go around the printer, so it is completely enclosed, and this is very useful for the ABS. But be careful, it may cause some problems with printing of the PLA. This is the spare nozzle, and I can see the similar one is in the extruder too. This is hardened steel nozzle, probably like with the KP3S, the version 2 with the Klipper version. But what is interesting that we have these open-end wrenches, but none of them is good for this nozzle. This one is too big, and this one is too small. So I'm not sure what are these for, maybe for the V-slot wheels, but we don't have them on this printer. When we open the box, we can see immediately this quick guide card, and the first step is always to remove the securing bolts on Y, X and Z axis. It's easy to find them, just follow these arrows here. This is securing bolt on the Y axis, this one is for the X axis, and on Z axis we have two of them. This is a stepper motor for the Z axis, which is lifted up with this lead screw, and we have this approximately 10 mm rods and big linear ball bearings. And this is very stiff solution, but I will measure the deviation of if I place here, I don't know, 100 grams of the weight. And I really like this flexible sheet, and this is two-sided version. I can see a lot of lubricant here, the grease on this lead screw, and it would be good to have some kind of backlash nut here, with the Z-hop, and it is more precise if you forget to place some lubricant after 1 year or something like that. This is the top of the printer, and don't forget here we will have a plexiglass, and this distance is quite small, so this will be pressed, and don't forget this is moving in this direction. I hope this is some long life heavy duty cable. Maybe it would be better to see some kind of drag chains or something like that, or maybe this distance could be a little bit bigger. Maybe we can even DIY some solution to lift the plexiglass higher, but let's don't rush so much. Properly this has to be inserted, but I will follow just the guide on the user manual. I already mentioned that on the website there is no information about maximal printing temperature, but here it is, 300 degrees Celsius, so definitely all-metal heat break is installed. And these are those speeds I mentioned, so theoretically the maximal speed is 500 mm per second, but the recommended printing speed is 350. But that's very fast too. It's time to install the plexiglasses, only first I have to remove this protection film. And be careful, don't over-tie these bolts into this plexiglass, because it may break too easily. I can see there is a small gap. Theoretically I could move this higher, but then below I have this gap. But even with this gap I believe that I can reach 50 degrees Celsius. If necessary, we can always place some kind of duct tape or sealing tape here. This is the top cover, and I can see some magnet strap. Oh, and it is so good feeling. The doors is finished too. Unfortunately it covers the touchscreen, but anyway with the Klipper you want to use the screen on your smartphone or on the computer. And later I will take out this protection foam when I leave the Z-axis higher over the screen. I can still see some gap here, and I think this side should be a little bit higher. So I will try to add 2 small washers between the hinge and the plate. In that case, this side will be a little bit higher. And now let's see. Okay, I can still see some gap here, but at least it is parallel, equal on both sides. This is the back side of the printer. Here we have the power switch, and this is the filament runout sensor, and this is the spool holder I have to mount here. I already measured the maximum thickness of the spool is 68 millimeters. I think this could be a little bit better here. And absolutely no instructions in the user manual that we have to connect the Bowden tube. I'm not even sure how can I connect it to the filament runout sensor, but inside definitely this should be connected to the extruder. This is the left side of the printer, and this is the connection for the network, USB plugs, and this is the connection for the camera according to user manual. It looks like 3.0 USB connection. User manual don't mention anything about the connection of the Bowden tube, but definitely this should be included because not everybody is familiar with this. So this ring I have to press down, insert the Bowden tube, and it will be locked in the position. But what about the other side? Again, this is the back side of the printer, and this is the filament runout sensor, and I believe that it should be connected here, but I cannot see the solution for this, or maybe I should just leave it to hang it like so, I'm not sure. The power cable, and before I turn it on, I definitely want to check the voltage if it's set correctly for my country. In my case it is 230 volts, I'm in Europe, in US it should be 115. Okay, it's time to turn it on. And I want to lift it higher so I can remove this protection foam. Very nice LED. And after approximately 40 seconds it boots. I can hear that some fans additionally starts with the working, which I don't think they are already necessary. Let's move higher a little bit the Z-axis. I will turn it off so far because I want to connect to the network. Later I will connect it with the cable because it is much faster, especially transferring bigger files. But first I want to set the Wi-Fi network. And for this there is a file on this USB disk, and I have to enter here my Wi-Fi username and password. Wi-Fi connection data is on this USB drive. Before I check the Wi-Fi connection, I need to change the language. I found it is this small gear. And again this small gear, going down, and there is Chinese simple, and I have to switch to the English. And now let's check the network. I am going to the configuration, network, and that's the IP address which I have to enter into the browser, and then I can connect with the printer. And after I enter the IP address into the browser, I can see the fluid, but first I have to change the language, and I found it, it's here, and now it's in English, and now back to printer. The leveling I am starting with Z calibration. Properly with this I have to set the Z offset, the distance between the nozzle and the print surface. And after Z homing, I am using the paper friction method to set the perfect distance between the nozzle and the print surface. And as always, I'm using 2 pieces of sheet because I'm not familiar with this surface, to avoid that the filament sticks too good to it. And now I can feel that friction, so the distance is set correctly now, and I can start the leveling. In my case, minus 0.94 and accept, which will probably save. And now bed mesh, which is something like auto leveling, and there is no profile, so let's record one. And this is a time lapse of approximately 3 minutes. Leveling is finished, and I can save the configuration. And I can even see the results on the screen. Well, between plus and minus 0.5 millimeters, but anyway it will be compensated during the printing, because here we don't have the manual leveling at all. And now let's do the input shaper, and the accelerometer is built into the head. Measure both. And now it will do some different vibrations, measuring the acceleration, and it will store the data later. Now it is the x-axis. It may be very scary, but don't worry, this is normal. And now it starts measuring in y direction. Okay, it's finished. Klipper will reboot. Okay, continue. It's saved the data and it's ready for the printing. I have to insert the filament. Not sure if it is visible on camera too, but I don't really like that the inductive sensor is very close to the height of the nozzle. I experienced this with the KP3S2, and if I will have some kind of curling on the printed objects, and it may easily hit the leveling sensor and it may break off. I'm cleaning the bed with some isopropyl alcohol. I preheated the nozzle and now I will insert this filament which was sent to me, and I can see three colors, yellow and some kind of red, and here I can see some blue color. About the spool, it would be good to see what is the weight of the empty spool, maybe some scale here under this hole, and it would be good to see more locking holes for the end of the filament. But I'm still confused why this is not locked into this filament sensor. Problem solved. Filament is partly inserted. Let's load it from the screen now. Macro load filament not found. Okay, it looks like I have a similar problem like with the KP3S. This is very new product and not completely finished so far. Of course, this error can be easily fixed with some updates by the Kingroon, but it would be good to get sometimes a completely finished product for the testing. Let's try the extrude. Ah, this works, okay. And I can see the filament from the other side. But as always from the package, I'm really missing these metallic tweezers. Now let's search for some prepared G-codes. Printing, Benchy fast, 20 minutes, 29 minutes. Okay, let's try the fast Benchy. Print. The start is good. I can see the first layer sticks correctly to the bed. It finished the layers in the 3 or 4 seconds. Well, wasn't even here. It's printed in 22 minutes, which includes the bed heating time too. Immediately after the printing, I want to check the bed adhesion, which is great, so I can trust this surface, and probably when it cools down, it will be easy to remove it. The bed is 35 degrees Celsius, so let's try to remove it now. And this is why I like this print surface, my favorite. And now let's analyze the quality, which is not bad. I'm not sure what is this line here, but I don't think it's issue of the printer because it is not parallel with the layers and it is presented on both sides too. But I think it's issue of the slicer they used to prepare this Benchy, and I can see maybe it could use some more part cooling or longer layer printing time here and on the chimney, but probably they prepared this to be printed as soon as possible. And also I can see that there is no ghosting at all, so this input shaping works correctly. And now I'll prepare the Cura and slice my own object. On USB drive we have the Cura configuration folder, and there is a readme file with instructions where we have to copy these files. And Microsoft Windows, it is in the Share Cura Resources folder, and we have to copy these files here. And then when we start the Ultimaker Cura, we will have a Kingroon KLP1 printer if we want to add one. And this will be my first printed object. I will start the printing from USB drive, but of course I can upload it over the network too. Print, USB, dice, print. This is the calibration tube, but also can be used as a D6 dice. Printed in 10 minutes. Definitely you have to wait until the bed completely cools down. Quality is good, no ghosting at all, and I already measured the dimensions. They are below 0.05 millimeters error, and maybe not the best filament for these dies because of these 3 colors, but I have a great object for this filament. This is a rotating element on Cylindrical D6 dies, which I'm using very often as a gifts for my family or business partners. The bed cooled down. And this one is printed in 58 minutes with the 50% infill, and I will reprint the same one but with the 50% speed slowed down, and I want to compare the quality. Even this 50% speed looks very fast. And now let's compare the quality. So this one is printed slower, but to be honest, visually I cannot really see the difference between them. And as you can see, for this is great filament, because how it rotates, it always changes the color too. Only now I notice how ugly is this seam line on the back side, and I'm not sure is this issue of the slicer, because I just recently updated to the newest 5.4 version of the Cura. And the same ugly seam line is presented on this dice. Here it is visible, and it is not presented on the Benchy, because this is not sliced by me, and could be really the issue of the newest Cura, I'm not sure at this moment. Don't forget that we have an enclosure, so it's time to print some ABS, and this is easy ABS from the Sunlight. I just got these filaments for the testing, and who knows, maybe I will test it exactly with this printer, but in this video I just want to print tweezers, because it didn't arrive with one. In Fluid Jobs, upload file, selecting the G-code, and over the cable the upload is much faster compared to the Wi-Fi, of course depend on your connection. And then right click on the G-code and print. I think this filament sensor is on very bad position, exactly in the center, so it should be at least here, or under the angle. Extrude, and the filament is changed. And it's time to close the printer, and later I want even to measure somehow the temperature inside the enclosure. This is the position of the sensor where I will measure the temperature. I'm using this gap between the door and the frame. And the screen is not visible at all through this glass, so I'm using my smartphone to follow the temperature, so do some settings if necessary. And the start temperature inside the enclosure is 42 degrees Celsius, and probably it will go up to 50. Oh, it will be so good to have some kind of light inside, but I can see the first layer and it looks okay. Just very quick look I want to show you. Let's put the light here. But it is very hard to see anything through this glass. It will be finished in a few minutes, and my settings are 230 on the nozzle and 90 degrees on the bed, and I didn't use any adhesive on the print surface, but I checked that Z offset with the preheated bed. And it is noticeably quieter when it is closed compared to the open when you are printing PLA, but don't forget, with the PLA you don't want to close it because you need much more cooling. The bed cooled down, so let's try to remove it. Ah, perfect. And now even this printer has the tweezers, and I know if they are from ABS, they can survive even short contact with the preheated nozzle. And what are my first impressions? Well, I'm really amazed that for so low price we can get very functional 3D printer. With this we can print even some technical filaments too. It is fully enclosed, the nozzle can be heated up to 300 degrees Celsius, hardened steel nozzle is installed, and with this we can print even some carbon fiber filaments. Pay attention that they can be printed with 0.4 mm nozzle, because some carbon fiber filaments require 0.6 mm nozzle to avoid clogging. Linear relays on X and Y axis, so this is really amazing. Now, I can still see that for Kingroon this is very new product type, and I can see some unfinished elements. Like this filament sensor. Position is exactly in the center of the spool, but it should be somewhere a little bit higher or lower, and this Bovden tube cannot be connected to this filament sensor. I'm not sure if it should be like so. Insetting of the filament in this reverse Bovden style is not so comfortable. Well, my method was that I was pushing it until I could press with my hand, and then going to the screen and going with the extrude. The load function for some reason doesn't work, so I can see some unfinished elements in the software side too. About the screen, it is not capacitive, so it needs to be a little bit pressed. It is very good that we have this pen, because it would be very hard to enter some numbers with the finger. And I think it should be outside of the enclosure, because of course with the Klipper we can use the screen of the smartphone or on the computer, but sometimes I just want to take a look to check the state of the printing or something like that, but I cannot even see the screen through this glass. It is very hard to see through this glass what is happening inside. At least I think on the top and the front acrylic they could use a transparent one, and definitely I would highly recommend to place some kind of LED light inside. We can add the camera too, because there is a plug for it, but we have to find a solution how to mount it inside. I hope the Kingroon will continue improving this product, because this can be a great product for this low price. Highly recommended if you want to print something else, not just figures but some mechanical parts too. If you have some other experience, through lines in the comment section. Thank you for watching and happy printing!